Whether it's because of gaming, the relentless march of technology, cryptocurrency, or whatever, graphics cards like these are incredibly powerful. They can do the job that they need to do, which is a specific kind of maths, very, very efficiently, very, very quickly. They are extremely powerful. Now, that processing power has been used in some areas for different jobs. So the reason I've got an RTX 3060, which I recently bought, is for rendering video. It makes my Premiere workflow much quicker, and I'm moving to DaVinci Resolve, which needs a graphics card to work at all. So why can't we use that for audio? Well, that's a question I've wondered for some time, and what I wasn't aware until somebody corrected my misconception on the Steinberg Beta forum, thanks Eddie, is that the UAD1, actually did use a GPU. So the processor on this is a graphics processor, but obviously this is from around the year 2000. So by today's standards, no guts whatsoever. So if you imagine you used a computer system from that era, it would be totally incapable of doing the kind of things that we take for granted today. CPU power has increased, but GPU power has also increased massively. I think GPU power has increased more than CPU power. GPU audio, funnily enough, is an attempt to make use of our GPUs to process audio. Now, this isn't something I've been paid to do. I just found out about this earlier this week and thought I should do a video on it, because if I hadn't heard of it until I saw a video from NAMM, probably other people won't as well. So the idea of this video is just to take a look at what is very early beta software. It's only got one plugin at the moment, which is a convolving reverb, and just to see whether or not it works at all. Obviously, it's early beta software, so there's a few rough edges, etc. But what we're promised sometime during the summer is a suite of other plugins, not just a reverb, which will make it more useful. But I thought it'd be interesting just to take a look at it in action, and also to see how it stacks up on my system compared to the CPU. So looking at GPU and CPU performance, and roughly like for like, seeing what you can get out of it. So here we are in Cubase, and first things first, you know, there's a bit of a break for the channel. We're in Windows. This isn't because I'm anti-Windows at any point, it's just because generally the screen capture is easier and simpler when I'm doing it on my Mac. It's definitely not powerful. It's definitely not the machine I use normally. But anyway, here we are. So GPU audio at the moment is Windows only. They are looking to expand it to Mac to use the M1 processor, etc. But we're just looking at this early version, which has not a great deal to see. It's more for potential and making you aware of what's possible. So here we are in a simple project in Cubase. So I've got two tracks which I've named sensibly. So we've got one which is GPU audio and one which is Reverence. This is just using these files which come with Cubase. So this is just from Media Bay. So there's nothing particularly interesting about the audio side of this. It's more the idea. So here we've got this loop, which I'm just going to play you so you get an idea of it. Nothing particularly interesting to see here, but the only effect which comes with GPU Audio's early beta at the moment is this convolving reverb. So this is an impulse response reverb. As you can see, it's just got a choice of 10 impulses. So you can select them here and you've got a mix control, and that's it at the moment. There's not really much to it. It is usable. Whether or not it's the greatest reverb in the world really comes down to, I think, probably the impulse responses. So we're just going to have a look at that in a minute. But first things first, let's just see it running. It's fairly straightforward. So we've got this as an insert on the channel, which generally I wouldn't recommend, but I've done that for reasons which will become apparent later on. And you can hear it works. Obviously, we've got mix control, so we can go from 0 up to insane and everywhere in between. So you've got that. That will all work. This will appear as an automatable control. So you can see we've just got the impulse response and the mix. So it works in every way as a standard effects plugin, as you would expect. There's nothing interesting about that. But what I think is interesting is that this offloads that processing to a part of your computer that probably isn't working that hard if you are of a reasonable spec and you're just using it for Cubase, etc. Because the Cubase graphics in Cubase are absolutely trivial to a modern graphics card. The only reason I've got the graphics card I've got, the RTX 3060, is for rendering in Premiere, and I'm moving to DaVinci Resolve, and I need a reasonable graphics card. We can see how hard the graphics card is working with this program called GPU Profiler. So GPU Profiler here is working away. We don't need to worry too much about the graphs, but the important thing is the GPU percentage. So we can see it's spiking a bit in there, depending what's happening in terms of if we change windows, etc. If we change impulse responses, that seems to cause a bit of a spike on it, but generally it can run at a fairly low level, and the way that it scales, I think, is quite interesting. So let's just look at that and see how many plugins we can get running. Now, I appreciate this isn't a particularly musical example because we only have one reverb available, and maybe you'd use a few in a track, but you would generally use them as sends. So this is just a pointless stress test, but the idea is to show how much power is available. So let's see how far we can go. So here we are back in Cubase, and let's just try stressing this. So all we're going to do is keep doubling the number of tracks we've got. So I'm just going to mute the Reverence version, which we'll take a look at in a second. And let's just duplicate that track. And if we play it, now I'm going to keep the audio level low on this because obviously the more tracks we have, it's going to get very loud very quickly. So if we look at the audio performance, so we can see that it's moving around a fair bit. Now this apparently is because of the early software which we're using, so this should be lower than this, and certainly what I found is this doesn't increase drastically. So we've got 2 there, and if we go back to GPU Profiler, let's take a look at what's happening in there while we're playing this. So you can see an early spike from where I just started from scratch. So this is what we're actually talking about, this area here. So we can see we've got some movement, but we're about 40% or so. It's the GPU consumption, but thereabouts. Let's double up and see what happens then. So now we've got 4 running. ASIO doesn't seem to have changed much. I'm still getting those occasional spikes. And this is when we had 2 tracks, this is when we had 4 tracks, and we're not seeing a great deal of increase. Let's double again. So here we are with 8 tracks. Again, we're seeing those occasional movements on ASIO guard. No real-time processing. A bit of a spike there. And it's settled down again. Now, you may be wondering, is this using the same reverb for all of them? It's not. So we can actually change these. So let's change this one to a 9. Let's change this one to 6, 5, whichever, etc. I'm just going to close those windows because we can end up with too many windows. But yeah, we can certainly load these up with different. Again, and we can see that that load isn't drastically moving around. Now, it's difficult to see exactly what's going on. Now, it shows us Cubase is only using 10% of the GPU. OBS is using some because I'm using screen capture, so that's something we need to factor in as well. You probably wouldn't be doing that all the time, but we can see we're not maxing the GPU out. So let's give it some more grief. Let's double again. And now I'm just going to turn the master level down. Just turn that up earlier on for testing reasons. So I'm just going to put that in the background because we're not concerned with the sound of it particularly. So we can see we've currently got 16 of those tracks running. And if we go back to Here we can see we're now starting to see a bit of an increase, so we're back up to this, although it seems a bit smoother. We're not seeing those spikes, but again, this is early days in this software. Let's double up again. So let's zoom out a bit vertically. Once more, duplicate those tracks. So now we're up to 32 of these reverbs running. Still seems happy, it's still pretty responsive. 24% GPU usage. Let's go to 64. Now we see a step up. Let's go once again. So let's go to 128. Now in my previous testing, this is what happened. So at this point, we got to a point where we ran out of GPU memory according to this. Now this is currently running at 2496 because that's one of the limitations of the beta version we're running. So you can see now we seem to have hit the buffer. So let's reduce that a bit. So let's take 32 of these out or so. So let's go down to there. And we can see just about getting away with that. Let's look at that. So you can see that load has come down to under 80%. Now, typically, when we're talking about VST DSP use, normally, as long as we stay considerably under 80%, you know, around the 3/4 mark is normally where I'm happy with most systems. So that doesn't seem to be too bad because then we're getting 96 convolving reverbs running all at the same time. Now, obviously, if we had more plugins available, we'd be able to do a bit more of a spread and see something more useful. But you can imagine if you have 96 tracks with in-depth, let's say channel strips running, you know, the kind of things that are pretty popular. So where you've got dynamics processing, EQ, etc., all that kind of thing, and maybe a bit of modeling technology as well. Imagine having 96 of those running without any CPU load. That would be pretty nice. So now let's see if we can get the same kind of performance from native using Reverence. So here we are back at some level of sanity where we've just got the track. So this is exactly the same track. Now, actually, what I did do to it is I phase reversed it because I wanted to see if there was complete cancellation if you had the same impulse response. I wasn't getting that, but there's too many characteristics which are unknown in a reverb. So while trying to use the same impulse response to make it fair in terms of comparing DSP usage, I'm not sure whether or not I actually achieved that. But one thing that's kind of interesting about this is if we load up a Reverence on this track, Reverence allows you to import an impulse response. So you can import an impulse response from anywhere. I'm not sure if you knew that, but that means you've got a huge range of different reverb sounds you can get. So impulse responses are all over the place. They can do all sorts of things. It's a really interesting thing that maybe thinking about it now, I might do a video on. But let's just import one of the responses which the GPU audio is using. So if we go to the folder where GPU audio is installed, so we can see there are impulse responses in this folder. So this is the default location for it in Common Files, VST, GPU audio, EAP. So here we've got these ones there. Now, the biggest one I think was Mausoleum. It's misspelled. I'll let them off. So we'll load that up, and here we can hear Reverence with those same settings. So let me just turn that up. Now, as I say, I wasn't able to do a complete comparison of the two. They do sound slightly different. If you phase reverse the one and put them together, they're not behaving the same way. But Reverence has got more controls here, and we're not really sure. It's a bit of a black box in terms of what actual processing it's doing. So a convolving reverb isn't a convolving reverb, if you know what I mean. They could be different things, and certainly here they sound slightly different, but this is definitely the response that we were using for the majority of them earlier on. So let's see how many reverences we can get out of this. Now, my system is not particularly powerful. It's a 9th generation Core i9. It's about due for a refresh, so I'm just waiting another few months until maybe something a little bit better comes along. But certainly I built a 12th gen system for somebody recently, and it was incredibly powerful and worked really well. So I'm not exactly sure which route I'm going to take. But anyway, just as a benchmark, this is an i9 9900. Let's see how many of these we can get out of it before it cries. So obviously with one, it's perfectly happy. Let's duplicate that. And now let's turn this down so we're not troubled by all this noise. So seeing what happens here. So this is going to be critical this time to see where we end up. So this is purely DSP based. So let's duplicate that. And now we can see that. Again, we get these slightly strange responses. It's never quite what you would expect. So here we are at 8 tracks. Now we're seeing a slightly more consistent load with the occasional spike here and there. And let's duplicate it again. So now we're at 16. And again, I can remember, it wasn't that long ago that this amount of processing power was just something of a madman's dreams. But we can see here now we're consistently getting 50% and spiking up. So this is around where I'd probably be borderline okay with it in a session. But you think, yeah, this would at some point would spike up more, particularly if you get a couple of other juicy plugins running. So we're probably getting towards the practical point where we'd be done. So that's at 16 reverence. Let's just duplicate those again, double it up to 32. And yep, we're still going, but now we're getting to a point where it's just maxing the system out. So you can hear that glitching. It's cutting out. Yes, I could spend some time adjusting system settings and this, that, and the other, but you can see that at 32, we're maxing out. Now, if we go back to monitor here, we can see the RAM load, the blue line here, the RAM percentage is going up. Now, I know from my previous testing, if I try and double this up again, the system will generally, Cubase will crash because we just get too much memory load, etc. But certainly we're getting a third of the kind of performance out of this that we were getting like for like with GPU audio. So it has the potential to allow you to effectively have 3 times the performance. You can have 3 times as many plugins running by offloading some to the GPU. So that was my potentially slightly unscientific take on GPU audio and how it stacks up compared to processing with CPU. Now, I appreciate that it's not a completely fair comparison because we don't know what processing each of those plugins is doing. It's unlikely that you would get something where you would have a completely comparable, exactly the same plugin on 2 different architectures happening. But in terms of function, I would say they were pretty much the same, although obviously the GPU audio reverb has fewer controls, but I didn't tweak any of the controls on Reverence. I think this is a really interesting development. It's something I've wandered around for a long time. Obviously, I didn't realize that the UAD1 did use a GPU until very recently, and I stand corrected on that point. But it's something which seems to be, to me, to be a no-brainer because there's so much maths processing power which is in a GPU, and after all, that's just what GPUs do, that being able to harness that in a DAW workflow seems like a great idea. Obviously, this will stand or fall on the quality of the plugins because clearly just a convolution reverb it's not that great. But if we could get some good sounding compressors, channel strip kind of plugins, etc., the kind of things that you might want across every track in your entire project, then that could be really good, because effectively having 96 channel strip plugins for free in terms of CPU load would be a great thing. So this is an area where I think it's got great potential, providing the right kind of sounding plugins happen, because after all, if they don't sound right, it doesn't matter whether they're using your CPU or not. You're not really going to care if they don't sound great. So here's hoping that they sound good, they have good processing potential. Now, also, the other thing is, hopefully they will be able to open this up so other people will be able to use the platform in the same way that pretty much anybody can create a VST plugin, etc., and have that running in Cubase with certain limitations. So if that happens and other plugin producers come on board, so the kind of people you've used and loved plugins from, FabFilter, etc., then that would be really a game changer as far as I'm concerned. Combine that with the fact that if you are running out of processing power at the moment, the only real way to resolve that is to buy a new motherboard, buy a new CPU, buy new memory, start from scratch, spend 3 days installing everything, yada, yada, yada. You know, it can be a pretty long-winded and expensive process. That's why I tend not to refresh my DAW every year like some people do. Being able to just plug in a new graphics card and maybe uprate your power supply and then suddenly have 50% more, 75% more processing power would be a really great thing. Now, obviously, this was just a test on an RTX 3060. With a 3090, you could really knock things out of the park. It would be interesting to see that, but I don't have the 1,500 quid spare to try an RTX 3090. I say all of this is unsponsored. There's no link with me to GPU audio at all, other than the fact that I'm interested in it and I've started playing around with it. Link is in the description if you want to try and download it. They are promising updates and a suite of plugins which would make it much more useful. So we'll stand and fall on whether or not they really are that great. But as ever, I hope you found this useful. And if you have, please like, subscribe, chat, etc. And we'll see you again soon for more Music Tech Tuition.